Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 4, Creating Histograms. Okay, classwork example 1 says frequency table with intervals. So we're doing a frequency table with intervals. The boys and girls basketball team at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell baseball caps, the school logo on the front, to family members and other interested fans. To obtain the correct cap size, students had to measure the head circumference, distance around the head of the adults who wanted to order the cap. The following data set represents the head circumferences in millimeters of the adults. Okay, so here's the list of all the head sizes that they measured. And it says the caps come in sizes XS, S, medium, large, extra large, and double extra large. Each cap size covers an interval of head circumferences. The cap manufacturer gave students the table below that shows the interval of head circumferences for each cap size. The interval 510 millimeters, less than 510 millimeters to 530 represents head circumferences from 510 millimeters to 530 millimeters. Okay, so it's from 510 to 530, from 530 to 550, right? But less than 530. So if it is 530, it would be down here, not up here, because there's no equal sign here. Okay, so we're going to do a tally. So 513 is between 510 and 530, so I put a mark here. 525 is also less than 530. 531 is more than 530, but less than 550. Same with 533. Here's a 535. Another 535. 542. And when we get to our fifth, we do a diagonal. 543 goes here. 546, still less than 550. 549, still less than 550. 551 is between 550 and 570. 552, 552 is two more. And we're going to count until so they've done this, they put these in order for us. So I'm going to just count until I get to 590. So how about I make it easier here? So 550 to 570 would be to here. And then the next one is 590, which goes to here. And then the next one is 610 and up. So there are my breaks. And so now let's continue counting. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 more that I have in this region here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 570 to set 590 is this group here that I've marked. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then finally this one here is 1, 2, 3, 4. 1, 2, 3, 4. And then the last one there are 2. So when we finish our tally, this is a little bit different. They put them in order for us. And the reason for tally tables is to put things into perspective with numbers that are not in order. So anyway, the frequency is how many times something tallied up. So there's 2 tallies there. There are 8 here, 15 here, 9, 4, and 2. Exercise 1 through 4, we're now going to answer questions about this frequency table. And it says, what size cap would someone with a head circumference of 570 millimeters need? So this says less than 570, but this says 572 less than 590. So the answer is right here. 570 is right here, and that is a large. Number 2, complete the tally in frequency columns in the table in example 1 to determine the number of each size cap students need to order for the adults. We've just done that. What head circumference would you use to describe the center of the data? So now when I come back and look at my frequency table, the center of the data I would assume would be right around here. This is kind of centered around 15. There are 15 of mediums, 8 small, 9 large. So we kind of center around the medium. So the head circumference would, to describe the center of the data, would be the medium, or you could use the size, and you'd say between 550 and 570. Okay, so 550 to less than 570. Number 4, describe any patterns that you observe in the frequency column. So if I go back and look at the frequency column, I have a small number, it's increasing, it maxes out at 15, then it decreases back down to a small number of 2. So that's what I would say. I'd say smaller, the extreme sizes, the XS's and XXL's have fewer tallies and more frequent S, M, and L's. So the values start small, get big, and get smaller again. That's another way you could say that. Okay, example 2, histogram. One student looked at a tally column and said that it looked somewhat like a bar graph turned on its side. A histogram is a graph that is like a bar graph, except that the horizontal axis is a number line that is marked off at equal intervals. To make a histogram, you draw a horizontal line right here. Mark the intervals. So this little squiggly line here means that this interval is a distance of 510. This distance here is a distance of 20. This is a distance of 20. They're all going to be distances of 20 because it's supposed to be even intervals. Okay, it says right here, equal intervals. So when we start really low, we don't want to have a frequency histogram that starts way over here and we have blank, 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 blank. So we draw this little jagged line that they have here. Let me erase it so you can see what they actually had there. And that is just telling the reader that there's a break in the data and it doesn't start until here. So we've kind of, it's almost like using a spreadsheet and you have hidden some of the cells. So each of these distances on the histogram, the intervals are all length 20. The second step is to draw a vertical line and label the frequency. Mark the frequencies axis with a scale that starts at 0 and goes up to something that is greater than the largest frequency on the table. For each interval, draw a bar over that interval that has the height equal to the frequency for that interval. The first 2 bars of the histogram have been drawn below. Okay, so let me just erase this little note I made here. Okay, so this is 2 and the next one is 8. So if I go back to my frequency table, they did the 2 and the 8. Medium is 15. So now I have to go back to this histogram and complete it. So medium, which is 550 to 570, was 15, and 15 is halfway between 14 and 16. So you draw a bar over like this, and then what I would do is just bring my line down here, like that. Try to be as neat as possible, and there's my bar. It'd be better to use a ruler, but I'm not going to take the time to get the electronic ruler out because of the length of time it takes to do that. So that is 15. The next one is 9, and that's 570 to 590. 570 to 590 was 9. 9 is halfway between 10 and 8. So that goes to here, and then draw a line down. The next one was 4, and then finally 2. So I'll just do both of those at the same time so I don't have to keep going back. So this one was 4, and the last one was 2. Okay, so there is our histogram. Okay, so number 5 says to complete the histogram, which we have done. Based on the histogram, describe the center of the head circumference. Okay, so now when we look at this, the center is between 550 and 570. And those are in millimeters. So I should have mm here. How would the histogram change if you added head circumference of 551 to 569 to the data set? 551 to 569. So 551 to 569 is in here. 551 to 569 is right here. Okay. Okay, so if I had someone at 551, they'd be in this on this bar. And if I had someone that was in 569, they're also between 550 and 570. So what I would do is increase the height of my bar by 2. So it would go from 15 up to 17. So if we had 2 more people whose head sizes were medium, then my bar would go up to there. That's what that question is saying right here. Number 8. Because the 40 head circumference values were given, you could have constructed a dot plot to display the head circumference data. What information is lost when a histogram is used to represent data distribution instead of a dot plot? Okay. Okay, so in a dot plot, you can see individual values. In a histogram, you only see the total number of values in a certain interval. Number 9. Suppose that there had been 200 head circumferences measurements in the data set. Explain why you might prefer to summarize this data set using a histogram rather than a dot plot. Okay, the reason for that is there'd be too many dots on a dot plot and it would be hard to read. A histogram would work for a large data set because the frequency scale can be adjusted. Example 3, shape of the histogram. A histogram is used to describe the shape of the data distribution. It is important to think about the shape of a data distribution because depending on the shape, there are different ways to describe important features of the distribution such as center and variability. A group of students wanted to find out how long a certain brand of AA batteries lasted. The histogram below shows the data distribution for how long in hours that some AA batteries lasted. Looking at the shape of the histogram, notice how the data mound up around the center of approximately 105 hours. We would describe the shape as mound-shaped or symmetric. If we were to draw a line down the center, notice how each side of the histogram is approximately the same or a mirror image of the other. This means the histogram is approximately symmetric. Another group of students wanted to investigate the maximum drop length for a roller coaster. The histogram below shows the maximum drop in feet of the selected group of roller coasters. This histogram has a skewed shape. Okay, so there's a new word for you, skew. Skewed shape. Most of the data are in the intervals from 50 to 170, so most of them occur here. But there is one value that falls in the interval of 290 to 330 feet above, and one value that falls in the interval of 410 feet to 550 feet right here. These two values are unusual or not typical when compared to the rest of the data because they are much greater than most of the data. Okay, so this data is skewed because we've got some larger numbers that don't make it symmetric. I don't have two smaller numbers over here to make this symmetric, and this does not match over here, and this, there's nothing over here. So this is what skew looks like. So this is exercise 10 through 12, and the histogram below shows the highway miles per gallon of different compact cars. So we're going from 28 miles per gallon all the way up to 52 miles per gallon, and the frequency of number of cars is in each one. So describe the shape of the histogram: approximately symmetric, skewed left, or skewed right. Okay, so this one does have this value sitting out here, and it's got this mound shape like this, but then it tapers over like that. So if I drew let me do that a little better. Usually when we describe shape, it's usually mound shape, but what's happening here is we go to the center, center, and if I just kind of came down and looked at the centers of these, this is how it's going to look. So this is kind of pulling off to the right, so that is what we would call skewed right. Okay, B, draw a vertical line on the histogram to show where the typical number of miles per gallon of compact cars would be. So if I drew a vertical line to show where the typical number of miles would be, I would probably say it's right around here, right around 34 miles per gallon. What does the shape of the histogram tell you about miles per gallon for compact cars? Okay, most cars get around 31 to 40 miles per gallon, so the majority falls within this center. But there was one car that got between 49 and 52 miles per gallon. Number 11, describe the shape of the head circumference histogram that you completed in exercise 5 as approximately symmetric, skewed left or skewed right. So now when we go back to the histogram that we created, that's this one, without that red added to it, of course. So we're looking at this histogram here. Would you say that was symmetric, skewed right, or skewed left? I don't see any values that are way out over here, and if I drew a vertical line right here, that is pretty close to being symmetric. Or maybe I could even move that line a little, yeah, right around there, I'd say. Let's just leave it there. So that is pretty much symmetric on both sides. So I would call that symmetric. So that's right here. So, and we're going to use the term approximately here. I call those fluff words. If you say it's symmetric, it's got to be exactly symmetric. So we have to say it's sort of symmetric or approximately symmetric. Okay, number 12. Another student decided to organize the head circumference data by changing the width of each interval to 10 instead of 20. Below is the histogram that the student made. So now we have a head circumference here. And when we make the distance for the interval less, we're going to have more intervals, and we're going to get a better representation of our data the more intervals we have. But again, we have to limit that because the reason we do these histograms is to save, because drawing multiple dots on a dot plot take up a lot of time and they're hard to read. So how does this histogram compare with the histogram of the head circumference that you completed in exercise 5? Okay, so let's go back and look at the histogram in exercise 5, which is right here. Okay, there are only 6 bars, and it looks pretty symmetrical. And then we go back to the other one, the new one, which is right here. Now we have 2, 4, 6, 8, 10, 11 bars. And now we kind of see that some of these go back up and go back up again, where before it was more symmetric. Okay, so my description of that comparison would be as, okay, so both histograms have the same general shape and center. This one's up a little higher, this one's up a little higher, but it is still kind of symmetric with taking those into consideration. Okay, B, describe the shape of the new histogram as approximately symmetric, skewed left, or skewed right. And I would still say that this is approximately symmetric. C, how many head circumferences are in the intervals from 570 to 590? So now we have 4 plus 5, which is 9. So I would just say 9. In what interval would a head circumference of 571 be included? 571 would be in here between 570 and 580. So I'll say between the interval 570 to 580. In what interval would a head circumference of 610 be included? Okay, 610 is less than 610. Or 610 equals 610. So what they're trying to explain to you is if you are right on the line, then you're going to end up in the next interval. So it's going to be in the interval 610 to 620. So the 610 one would go in this one. Okay, that is the end of lesson 4. Go do your problem set. And oh, by the way, smash the like.